Okay, so this is the beginning of Unit 2. We are picking this up where Unit 1 left off. So if you didn't take notes, it's probably not going to be a huge deal, so don't sweat it. It's one of the rare times where you won't be totally lost because there is such a strong carryover here. So we reviewed average rate of change and instantaneous rate of change. You reviewed a slope point formed right in the equation of a tangent line, which again is always up at the front of the room on an anchor chart, right above the bulletin board. You learned, this is the big new thing, you learned 5 notations for the derivative. Okay, so what, if you took the notes, what you learned is the term derivative just means slope of the tangent line. Okay, so we were calculating that when we used the limit method back in Unit 1, that we are now going to call the derivative. Okay, and for reasons that we'll get into in this unit, by the different name. You learned that once you see the words estimate or approximate, we do algebra. Right? If we say approximate the slope of the tangent line, it doesn't want you to do any calculus. It'll probably give you a picture with a tangent line. You can do a nice rise over run, or it'll probably give you a table with a bunch of points, and you can just do a nice rise over run. You learn that the slope of the tangent line is the value of the derivative. They mean literally the same thing. That is what the definition of the derivative is that it's that value of that slope of that tangent line when you do the limit method. Okay, and like I said, we'll make a stronger connection as to why that is so as we get into this unit. So the big takeaway is we can answer a calculus question without doing any calculus. We just do algebra at this point. Okay, and so that's the big takeaway here. And this is particularly appropriate or applicable when you have graphs and tables where you can do a quick rise over run. So any questions about that? Okay, so this was from the notes, and I just want to go over a few kind of subtleties here. You don't know the word concave up, but this is concave up. Okay, I think of concave up as kind of like a cup. It can hold water. So that's what the concave up shape looks like. We'll talk a lot more about that later in the course. And then of course we know the term linear, big smiley face there. So we see this verbiage, approximate the value of the derivative. Okay, this is one of the derivative notations, it's f prime. So that means the derivative of function f. So I see the word approximate, it tells me to use the table, so all I'm doing is looking at values here. So here is 4.5. Notice here's 4.5. Okay, and so we got to do a slope for that tangent line. And so you might think, well, let's grab the point at 4 and the point at 5, connect those points, and that would be pretty close to the tangent line, right? And that would make sense if the dot up here was filled in. But unfortunately, it's not. The value is down here. So look in the table, the value is that filled in dot. So we can't use that value out of the table. And we don't know this value for sure. So we literally have to use those two values. We literally have to connect these 2 points and do the algebra slope there because of that piecewise function. Okay, so these are the little things that they might be able to get you caught up on. So the other thing about tables is that the y is always the second row, which means that in order to calculate the slope correctly, you have to look at that table and flip it in your brain. Does that make sense? So that your function values are on the top. So we take y2 minus y1 over x2 minus x1, and here's our slope. We're done. We walk away. We don't evaluate it. That's the grader's job to evaluate it. This is one of those time-saving things. Okay, I get to evaluate that, but I know these numbers are correct, so I just give you all the credit and I move on. Okay, for those people that really want to know, it's 1.32. How are we doing so far? Okay, so the first subtlety, reading a table and realizing that sometimes you can't pick the point on either side. Sometimes you have to pick the point itself. The other subtlety is this. Is there a value from 0 in the domain from 0 to 5 such that the limit at h approaches 0 is f of x plus x over h equals 0? That's our limit method, right? But they don't want you to do the limit method. When they start throwing this stuff into questions, they want you to take a look at this whole expression, and instead of thinking of it as the limit, they want you to look at that and think derivative or slope of the tangent line. Okay, that's what they want you to think. So tangent line, slope, or derivative. So this question is really, where is the derivative equal to 0? Or where is the slope of the tangent line equal to 0 in this domain from 0 to 5? What location? What x value? Approximately 2, right? So this is a visual call. We're going to say that we have 0 slope right there at x equals 2. Give a reason for your answer. Because the slope is 0. The justification is right there. Okay? Or because the tangent line is horizontal. Actually, I kind of justified it twice, which is okay as well. Does that make sense? So that's kind of how we're approaching these things. So if you didn't take the notes, I'll come back to this page if you really, really want them, but let me just go on to the next page. How are the terms rate of change and slope related? And where does the word derivative fit in? So tell me what derivative means. Perfect. Slope of the tangent line. Okay. So we know that we have an average rate of change, and that is the algebra slope. We know we have instantaneous rate of change, and that is the slope of the tangent. And then we know that the slope of the tangent is the derivative. Okay. So in your topic questions, it's literally going to be asking you, what is the derivative? What is the derivative? What is the derivative? And you're going to look at tables, and you're going to look at lines, and you're just going to estimate, hey, is that line sloping positive? Is it sloping negative? Is it sloping horizontal, which is 0? Is it sloping vertical, which would be undefined? And is it, we always compare things to 1. So we know 1, slope of 1 is like up 1 over 1, up 1 over 1, right? Or up 2 over 2 and up 2 over 2. So we know the slope of 1 is 45 degrees. So if it's steeper than that, then we know it's a slope bigger than 1. If it's flatter than that, then we know it's a slope between 0 and 1. Okay, so we're going to be making those approximations. Okay, so we have notes for tonight. Go ahead and get started on the topic questions and crank out these cons. And these cons are all very much the same thing. These are eyeballing. This is algebra slope, the first one. The second one is eyeballing the slope of the tangent line. And then the last one is doing that, but then writing the line of the equation of the tangent. Okay, so go ahead and start working on those. Please, we're going to PowerPoint first. Okay, we're looking at those topic questions. Go ahead and grab an elbow buddy. You know, what kind of all of our buddies? Our buddies are gone, so find a new buddy. So this helps to talk about these things. Okay, and does anybody want me to go back to that earlier screen? Okay, because if you want to get, I'm going to go away from that. I'm going to go back to that earlier screen. Whoops. I'll freeze it on that earlier screen for a little while.